another promising alternative energy for future energy production. And this is very much in the future because this is still very much in research and development and has not been established or really used, is nuclear fusion. So the sun is an example of nuclear energy. And this is different from the fission reaction. It's also different from any combustion reaction. Even though the sun looks like a giant fireball, it's not a fireball. It is not a combustion reaction, because we know that combustion reactions is something that's burning. It's not something that's burning. What it is, in fact, is a lot of heat energy, but it's an enormous nuclear reaction due to the fusion, this is the fusion here, of hydrogen atoms. And fusion is different from fission. In fusion, these atoms come together instead of breaking apart, and these hydrogen atoms come together and form deuterium. This is one of the hydrogen isotopes. This is H2. It is the hydrogen with the one proton and one neutron, so shown here. This is tritium. This is the hydrogen isotope H3. It's the hydrogen isotope with the one proton and two neutrons, so with a mass of 3. So this is also the major product that you're more familiar with is helium. So helium, this is the element symbol He. There are also more neutrons produced, and most importantly, a lot of energy. Okay, and this energy is not just this little arrow, but a giant arrow, and this is energy for the entire universe. We receive as well as energy all the way out to every single planet in our universe. So this produces a ton of energy, and that's the idea, at least in research and development, is can we get atoms to fuse together? And it requires a lot of energy to start. And I'll underline a lot. So it requires a lot of energy to get this started. But then it will be a chain reaction. And remember, we talked about the chain reaction with the fission, is that the chain reaction, once it's started, it will continue spontaneously on its own as long as there are reactants. So this will continue to produce energy, but it requires a lot of energy to get started, and that's the possibility is not there yet because we haven't achieved this. How do you get enough energy to get this started first? So this is the holy grail of chemistry and physics, is what's called cold fusion. So this is, the sun is already pretty hot, and this all has been going on for 4.5 billion years. There was a lot of energy to get that started. Can we replicate this and make this not as hot as the sun, but so not cold like ice, but not as hot as the sun? And so this is, as I mentioned, the holy grail of both chemistry and physics, is that can we get a nuclear fusion reaction to happen, and then we could get all this energy out of it. Okay, hasn't happened yet, but there's a lot of scientists working on it. So we know for future, we are going to need energy. We're going to need electricity and lots more of it. We've only been on an upward trend of needing electricity for the last decades because of our reliance on electronics and the internet. So what we currently are using is non-renewable energy sources. These are the coal, oil, and petroleum, and natural gas, methane. Nuclear is also considered non-renewable because it has so many issues. Okay, it's something that does not have carbon dioxide emissions or air pollutants, but there are all those issues we talked about. Now, renewable energy sources, these are sustainable in that there's no carbon emissions or air pollutants when these are operational. There's some, there's startup issues with, say, making solar panels or building a geothermal plant. But once this is, the energy source is operational, there's no carbon emissions or air pollutants. Okay, these are also natural resources. So these natural resources can either be regrown or are not depleted, like sun, so that's solar, or hydroelectric would be the river, and geothermal, this is energy from the earth. And so this is wind as well, but biomass is, we talked about that briefly, but that would be, we could grow trees and, use that, or use animal dung. And wave, we definitely did not talk about, but waves and biomass, all promising, but not used, and so that's why we didn't get to talk about them. But these are all considered natural, and these are not depleted, or they can be grown, or they're not depleted. So we know that our energy sources are limited, and we must make use of our energy resources wisely and conserve what we do have. But we also have to develop new energy sources that are sustainable and renewable. Okay. So these are all very much for the future, and hopefully to see more of in the future. What we'll also be seeing more of future, and what we need to talk about in the next chapter, is storing energy. And so this is especially important for wind and solar, because we don't have wind 24/7. We don't have sun 24/7. So to make the greatest use of wind and solar, you're going to have to talk about how we can store energy that has been generated. And so that will be the next chapter.